Hello, everyone. My name is Michael Murphy, and I'm the GCP Practice Director with SoftServe. And today, what I want to talk about is a topic about revitalizing legacy healthcare with application modernization. In our agenda today, I'm going to give you an introduction. Oh, sorry about that. I'm going to give you an introduction, insights from Google, the what, why, the why, what, and how of Anthos. I'm going to talk a little bit about app modernization, give an overview of a customer case study with Anthos at SoftServe. I'm sorry, I just got to move this a little bit down. All right, this thing is a little bit in my way. Let me just get this out of my way. I'm sorry, y'all. GoToWebinar is not my general, not my general use. All right, there we go.
Michael, what I might suggest is, why don't you turn off your camera, and that might make it a little easier to put the mouse in a different location.
Perfect. I'll just turn the camera off. There we go. That should be pretty visible. Okay. Sorry about that, everybody. Then the last part of the agenda will be questions and answers. What I believe is application modernization really helps you to protect talent, improve efficiency and productivity, and really enable scalability for the future. A little bit about a background of SoftServe before I start talking about the case study that I brought to talk to you today. Us in the industry have one of the highest net promoter scores. We have an NPS about 150% higher than our nearest competitor. We've delivered over 10,000 complex projects on time and on budget with very little disruption. And we're growing at a scale of 1.7 devs an hour for about 3 years running. We're a global team. We were founded in '93 in Lviv, Ukraine, by 2 PhD professors. We have about 9,000 employees globally. We have over 400 members in our cloud DevOps competence groups. We call it a Center of Excellence. We have 700 engineers with cloud certifications, and we have over 1,000 engineers with cloud experience in multiple areas, not just Google Cloud, but multiple cloud and cloud menus. A little bit more about me. I am the GCP Practice Director at SoftServe. I previously worked at one of my first cloud positions was way back in the day at Rackspace. I worked in a project called OpenStack, helped stand up the very first piece of OpenStack hardware. Through my career, I've worked in a lot of cloud-related areas. I worked in support, systems administration, built data centers, worked on tons and tons and tons of solutions. I'm a GCP certified architect, and I've worked with such cloud vendors as Hewlett-Packard, Canonical, and Google. So the story or the case of the technical topic that I want to talk to you about today is a healthcare company they can't name, but they are a long-standing trusted health provider, and they have a complicated and diverse portfolio of tech solutions. So they engaged both us and Google, to help enable hybrid delivery across their portfolio, both their existing platforms and their upcoming platforms. So just realistically, when they contacted us, they had a lot of technical debt. They had a VMware solution. They wanted to expand into cloud and cloud services. They had heard a little bit about this new kind of product called Anthos from Google, and they had begun a journey within services and with microservices, services containerization. They had already started trying to implement or roll their own version of Kubernetes, but they were faced with a lot of challenges. So the challenges they faced were a need to refactor their entire CICD process, their whole practice, to keep up with speed to market delivery, their best practices, the evolving workforce they have, and the level of talent or backgrounds that the workforce that they were hiring in. They needed to repurpose their existing private infrastructure. They were unwilling to deprecate their recent hardware purchases. They don't want to write them off, and they also know that because of the fact that they are a healthcare company, that they are going to face regulatory requirements that are going to have a need to be in a single tenant controlled environment within their own walls, especially healthcare dealing with PII data. There's absolutely everyday use cases that they have that they can't just move off to the cloud and kind of go with a single cloud venue and option. They needed to improve their deployment automation to be able to utilize all branches of cloud or their on-prem capability. They just needed basic hybrid Kubernetes delivery service for a multi-cloud platform. Being healthcare, they also knew that the customers they were serving are global, and they needed to be able to serve the content to them globally across multiple DCs, and they needed to do so for critical medical front ends, which would require maximum amounts of uptime. And they also understood that as a healthcare agency, with the onset of GPU computational workloads or GPU optimized workloads, things like protein folding, gene splicing, deep data research, that they were going to need to be able to utilize GPU computation in a simple and easy manner. So overall, we've been working with this customer for over 8 months now, and we've delivered several of those solutions. So Anthos is the primary component of what we believed helped stitch everything together. And Anthos, for those who aren't super familiar with the GCP portfolio, I'm just going to give a small explanation of Anthos. Anthos is kind of a tagline for all of the products that Google makes available for multi-cloud and hybrid cloud delivery. The primary component of Anthos is something called GKE on-prem, and that's the ability to take a Kubernetes distribution that Google has developed and then install it on top of private infrastructure, private virtualized infrastructure, predominantly VMware. So individuals who have a VMware presence can tie it in and don't have a way to distribute containers on that VMware cluster, because VMware is infrastructure as a service, it's not PaaS. It allows a customer to take GKE on-prem and install it over VMware and turn VMware from IaaS into PaaS, all managed through Google, and with the ability to take workloads and redirect them from private infrastructure to and then move it over to a cloud-based GKE controller within any of Google's data centers. So Anthos is a big part of enabling multi-cloud and hybrid delivery for consumers who are interested in those types of workloads. So continuing on the solutions, we gave them an Anthos multi-cloud solution. We overhauled their microservice architecture and CI/CD delivery. We repurposed their existing VMware managed infrastructure to be Anthos managed. We handed them a brand new deployment pipeline. We helped to design their new global load balancing across multiple DC architecture, implemented it, tested it, and we developed a GPU pass-through capability that had not been solidified on Google before that. And I'll give a little bit more information about what that is later in the diagrams. So here what we're looking at is a general visual architecture of the current status of what we're doing with our customer in name. Typically, what SoftServe, the way that SoftServe likes to interact with cloud customers in these kind of a scenario, is we go through an assessment. The first thing we start with is an assessment. During the assessment, we gather as much data about the environment as we can. We ask all the right questions. We learn as much as we can about the environment. We'll take dumps from the hypervisor. We have planning meetings. We start bringing in different experts from data side, from AI side, from infrastructure side, from CI/CD, and we begin to put together what we call an architecture vision. And part of developing the architecture vision is what the architecture, the visual architecture will look like. This is one of the high-level designs, so it's not, even though it's a busy slide, it's not everything. It isn't representative of every node and every cluster, but this is a general idea of what it looks like, how we put this together, right? So we have an admin workstation where GKE or kubectl commands can be ran across. We have a vCenter API, which is our interface with their vCenter clusters, etc. And then we have down here where you would see production, staging, and share services. This is how each of the environments, whether it's deployed in VMware or if it's deployed on GKE, which is in cloud, each of them has a production, staging, and shared services home where any of the services can be moved through all the different portions of CICD. So in CICD, you would have things that are being worked on, deployed to staging, and then and then things that are ready to move to production. Shared services is where you run services that both staging and production would utilize. And then I have a better example of how we handle the load balancing later on, so we'll speak to it there. I do want to talk about a little bit here different, we're GCP, we're kind of GCP focused in these deals. This is a go-to-market deal that we did with Google. We try to use Google services wherever possible, but sometimes just because of our workbench, our experience, we will use third-party solutions that also make sense, right? So while there may be a GCP solution for some of these things like deployment manager, we tend to prefer Terraform because we're a very Terraform-centric shop. So that's the level of that we use. They already had some of these decisions are made based off of technology decisions they made or licensing they had previously, such as GitLab and Citrix. These were solutions that that our customer was utilizing previous to us becoming involved in the account. The GCP services we did deploy for this account are Google Kubernetes Engine, Anthos, Google Container Registry, and Anthos Config Management. So one of the solutions that we have helped to develop and deploy at this specific customer is global load balancing. As we said earlier, medical use cases absolutely have a need for being able to serve content across the globe. With Kubernetes, Anthos and Kubernetes specifically, it's relatively easy to deliver the compute side of applications globally. The harder part is data, shared database services, how databases update, where in the globe, databases are reading information or loading information. That kind of becomes a difficult say. But Google offers several tools to really help push a global application or global applications. One of the examples of that is a product called GCP Scanner, which really removes a lot of the difficulties of having to really choose a relational or a non-relational database. It has fantastic read time, response time. It's a great product to build global applications. We're also utilizing Citrix here as a load balancer on the front end because this specific customer was already a heavy Citrix utilizer, and so we've set up the data centers. They have 3 in production. So we kind of set up all of the data centers to be a failover based off of a Citrix load balancer. We have DC1, DC2, DC3 later on the chain, but each of them have an admin workstation with administration clusters, each of those clusters containing a production, staging, and shared service environment. Requests can be routed back and forth between, and they're routed based on the least path time to each user. So users who are regionally closer to either of the data centers are routing the requests. However, if there's to be an issue, some sort of zonal issue or regional issue or availability out of either of these DCs, and this is their private infrastructure, then it would either be routed to a cloud endpoint, like a GKE inside of cloud endpoint, or all requests could be, totally failed over into DC2 or DC3, for example. So this customer has the ability to prioritize workloads and place workloads both internal on their private on-prem infrastructure or within cloud, those that are cloud optimized or make more sense to run in the cloud, and they can fail over between any of those locations with ease. So earlier we discussed, or earlier one of the topics that I brought up was GPU and GPU processing, right? So as medical companies become better at utilizing data science tools in order to do data-driven research, they're finding more and more reasons to use GPUs, even TPUs, to an example, another product that Google offers, and be able to use them to prioritize medical research. So it was really important that we develop or kind of gave them the capabilities to have 2 different types of node pools, right? So a node pool is the nodes that are available to a GKE cluster to utilize for whatever services or whatever workloads that you want to run on top of them. we basically built all of their admin clusters have two different node pools, one with attached GPUs and one with no attached GPUs, which allows them to essentially label VMs and label in their CI/CD or in their delivery pipeline how they want their workload, whether they want their workload on clusters that have GPU support or don't have GPU support. And then be able to process or continue those workloads based on wherever the tagging will land the workload in the correct type of node pool, where they can easily either utilize GPUs if they need them or don't have to utilize node pools in there. So we're beginning okay, sorry. And then the last thing I really want to talk about is, oh, no, not the last thing. The next thing I want to talk about is the CI/CD GitOps approach. So when we approached, when this customer and us began or engaged in this deal, their CI/CD story wasn't much more complicated than having a Jenkins implementation or instantiation. We have brought several other tools, or the leadership that we brought to the account was to flesh out and to build an actual usable CI/CD GitOps approach for this customer versus just kind of what they already had there. And this is one of the values that we can bring, being very DevOps focused and having a lot of senior thought leadership and expertise around CI/CD, is to be able to come in and say, okay, here's what you have now, and based on where the industry's going and what we've seen and what we've implemented or developed for other customers, here's where we think you should go. And this is a big piece or important part of the story. So we were able to bring in other third-party solutions that they weren't using already, like Artifactory, Flux, and Helm, and work those in and tie those in to continue to work with GCP services like GKE, Anthos, etc. So we've built a fully implemented, and this is just a visualized diagram of how their CI/CD dev environment push kind of chain works. The last thing I want to talk about today is just to give you a visual overlay or an example of their Terraform layout. So we have built a whole new Terraform strategy, infrastructure as code for them. The primary purpose of bringing Terraform into an account, especially an account that hasn't used it before, is to increase deployment, increase deployment time, and increase deployment ease. So the more that you can wrap into Terraform and Terraform deploy, is the less manual building any customer has to do. And one of the most frustrating or time sensitive or time consuming concepts is building an environment out, building the environment out to be to the right size, to the right specs, tearing that environment down, rebuilding and redeploying the environment in a different location, any type of disaster recovery, bringing an environment up in a place that it's never existed before, so that you can use it as a disaster recovery zone, etc. So we kind of we set up like a feature fix branch, main branch, an entire Jenkins pipeline for this customer. This Terraform layout has to work both with GCP and VMware at the same time because of the nature of the hybrid delivery model that this specific customer is using. In order to be able to work. So Terraform has to work being able to request GCP resources, and it has to be able to work requesting VMware resources to spin up, etc. So it's something that we were able to design and deploy for this customer in a way that they can utilize it in the same method. So Terraform removes kind of different management practices that you would have to, someone would have to be trained to provision and set up environments over on VMware. The same thing for deploying using G-Cloud tools or G-Cloud tools to deploy cloud resources. Terraform allows that management to be uniform. It allows it to be faster, and it allows it to be repeatable and to be torn down and done over and over again. So in summation, I just want to touch on some of the business outcomes that from the start of this account and meeting with them and learning what they wanted out of the future of their business, to going through an assessment and learning as much about their environment as we can, and making suggestions and changes to how they did their hybrid delivery model, to how they built their CI/CD approach, to implementing infrastructure as code with Terraform. Really, the outcomes that we feel we delivered was to enable a reproducible and redeployable system. We decreased their operational cost. We changed the company delivery and operational culture around their entire process, and we enabled scalability for the future. Thank you all so much for your time.